Welcome to the 6th day of me solving one algorithm a day. Today's algorithm or challenge is migratory birds. You have been asked to help study the population of birds migrating across the continent. Each type of bird you are interested in will be identified by an integer value. Each time a particular kind of bird is spotted, its ID number will be added to your array of sightings. You would like to be able to find out which type of bird is most common. Given a list of sightings, your task is to print the number of that bird. And if the two or more types of birds are equally common, choose the type of the smallest ID number. For example, assume your bird sightings are of types 1, 1, 2, 2, 3, so a number represents a type, and there are two each of types 1 and 2, and one sightings of type 3. Pick the lower of the two types seen twice, 1. So the most amount of seeing, and then if there are equals, the one with the lower number, basically. Alrighty, and it goes up to, the number is smaller equal up to 1,000,000, and is the size of an array, and then each element, and space, yeah, and then array, the number could be 1, 2, 3, 4, 5. Alrighty, then let's get to it. That would mean we want to count. What we could do is we could say let dict for dictionary grouping array by the number. I am not sure if that really is the most efficient way to do that, because we are kind of, I don't know what's the underlying algorithm to like group it, but we for sure are looping through the array of some sort. And so now we should have something like, 1 and then say 1, 1, whoops. And then we should have say 2 and then 2, 2, and then we should have 3 and then 3, given that is the array, which means we have the counts basically for each element or for each seeing. Let's comment this one out. But it is given that we have definitely n is at least 5. So 1, 2, 3, 4, 5. We have at least 5 seeings, which means we should be able to say key value or element in dict, and then we have element and we have key, which represents the 1. So we could say var id lowest id equals just 0 for now, and then we can say if element key is smaller we will stick with 0, right? Let's say 1. We cannot. No, we do need somehow the first thing, and I don't want to. Okay, so dict first and then key. This is optional. Basically, I could say force, because we know there's going to be an element there. Alrighty, so then let's just see if element key is smaller than lowest ID, then highest seeing is dict first key value count, since we want this one and the count of the array. So if the ID is lower and highest seeing is lower than element value.count, we want to replace it. Lowest. It feels so inefficient. Let's see if that's efficient enough. Element key and highest seeing equals element value count. Correct? Hopefully. And then we return the integer. What is the output? 4 is the amount of seeings with the lowest ID. So then the amount of seeings is highest seeing. Run. Okay, wrong answer. Input, your output is 3. Expected is 4, obviously. So what's going on here? Why do we have 3? The first thing we are getting is 1, right? So then this element, number 3, should be there once. So if height as seeing is smaller than element value, oh wait a second, smaller equal to, because it could be as high and then we want to have the, oh one sec, just if it's, wait, we're actually just interested at first for if highest seeing that we currently have is smaller equal element value dot count. Only then we want to do something about it, or just like check. So if it's smaller or equal, then we want to say, okay, is the lowest ID we have bigger? That's the thing. It should be bigger. No? I think so. What did I say here? I said 4. I said 3. 1, 2, 3. Why is expected? Oh, wait a second. Sample output. Number 4. Okay. So then actually, not highest seeing is expected, but lowest ID. Lowest ID is expected. Okay. So maybe I don't have to do anything about it. Although I feel like this is wrong. No, it's right. Okay, I just mixed up the positions here. I can put it over here and say higher, like this. Okay. Okay, now all the test cases are wrong. Your output is 1, expected output is 4. Lowest ID, if lowest ID is higher than element key, yes. And highest seeing is smaller equal element count. Then we want to go in there and override, which should be, am I having, so for 1, we have the first count, which should be just 1 and 1. And then we go over it, and then for example for 4, we say the key, oh, if the lowest ID is higher, if this one is smaller. Oh, I see. Okay, no, so that's the thing. Yeah. So yeah, we do indeed. What I'm doing is like, I am also saying, requiring that the ID has to be smaller, which is not true. Like for this equation to overwrite, this should overwrite all the time when we have a higher count of seeing, and in case on the top, not like at the same time, but afterwards, basically, it should also look okay. If you have high equal seeing, then overwrite the ID. Let's write it out. So let's see. We are interested in that one first. We're going inside here. Now, oh wait a sec. We can say if it's smaller. Else if we can say this one. Right? So if high seeing is smaller than the current elements count, we're overriding. we're overriding. If it's equal, we can delete that. If it's equal and lowest ID is higher than element key, only then override. Which we can make this one an or, right? So we could basically say here or, and then this whole expression, and then we don't need an else if. So either high seeing is not or the highest we have seen yet, and there's something better, then we overwrite. Or if there's nothing better, but it's actually equal, then it also has to be a lower ID in order to overwrite. Okay, let's see. That works. Submit. Crossing fingers this is efficient enough. And it was. Awesome. Okay, got it. Thanks for watching. That was the algorithm for today. If you enjoy these kind of videos, if you enjoy this format, hit like to let me know you like it, and also leave feedback if you want to in the comment section, and subscribe if you don't want to miss out on tomorrow's challenge. See you then.